All right, good morning, good afternoon, good evening, whenever you're watching this video. Hope you're doing good. Today what we're going to be talking about is kind of a piggyback onto what we talked about yesterday. We talked yesterday about inscribed angles and how the measure of those inscribed angles are going to be half the measure of their intercepted arcs. And so I hope that you fully grasp that. If not, like I've told you before, go on to YouTube, look up some videos. You'll probably be able to see some more things there, and hopefully that's helpful. For today, what we're going to be doing is talking about angles that are inscribed, but they're also on the circle. And so let me actually pull up something that may help you as you look at this, starting with this picture right here. Okay, this picture right here actually shows you the inscribed angle like we just talked about, and how the measure of that angle should be half of this arc that it's intercepting right there. Okay, and as you notice, they're going to move this point A along the circle right there. So as we move it along, does the measure of this angle change? No, because points B and C are still the same. The circle is still the same, so the degree here, which is the same as the degree over here, if we take half of that, we get the same angle measurements there and there. Okay, and so as we progress through and continue to move this point A closer and closer to point C, what I want you to see is that the measure of that angle does not change. The measure of that angle, this angle, does not change. And so as a result, whether the angle is inscribed like you see on the first three pictures, or whether it's on the circle with the tangent line like you see right here, the measure of this angle is going to be half this intercepted arc. Now, as I began to think about that, in your textbook on number 45, they actually ask you to prove why that would have to be true. And here's something I want you to think through with me, just to kind of set a more solid foundation to the concept I just introduced. And so here's what I want you to think through with me. The measure of the degrees here, as we rotate all the way around this picture, or this circle right here, we know it's going to be 360 degrees. Okay, I think everybody knows that. That's good. 360 degrees. Okay, and what I see here is that there's a certain degree here, obviously less than 180 because it's less than half the circle, and a certain degree here that is greater than 180, greater than half the circle. Okay? Now, I want you to keep that in perspective, and we're going to look at the other angles that are within the picture, which would be this angle here and this angle here. Okay, so think about that. Well, what do we know about these two angles? Well, we know that the sum of those two angles is 180. You told me that the measure of the degrees of the circle were 360. Relationship there. One's half as much as the other. Okay? If we take that a step further, this angle here has to have a relationship with this angle here, and this angle's relationship is tied to this arc. This angle's relationship is tied to this arc. And so if you think about it, if the sum is 360 and the sum is 180, then this arc measure divided by 2 would have to be this angle measure, and this arc measure divided by 2 would have to be this angle measure. Okay, so I hope that made sense to you. If not, we're going to practice a couple of problems so you can see what I'm implying here, but that's the gist behind the concept that we're going to be looking at. All right, now let me get this up here. All right, and we're going to take a look at the worksheet from yesterday. So if you don't have that worksheet out, I want you to continue filling out the rest of the worksheet here. But Theorem 1110 says this: the measure of an angle formed by a chord and a tangent line is half the measure of the intercepted arc. Okay, half the intercepted arc. All right, and so for number one, if we go down there and apply this concept there, you notice that we've got a chord right here, and we've got a tangent line. And so there's several different ways you can figure out the measure of x. One way would be to say, well, I know that this angle right here is going to be half the measure of the intercepted arc of 220. So this angle measurement right here is going to be 110 degrees, okay? Which again is half of 220. Now from there, you also know that these two angles, this angle here and this angle here, are supplementary. So if I take 180 minus 110, I'm going to get this angle measure, which is 70 degrees. Okay? Now, you could have also figured out that same angle measurement by saying, okay, I know that this is 360 degrees. If I take 220 from that, I'm going to get this arc measure, which is 140 degrees. And then from there, I've got a chord and a tangent line. This angle is going to be half as much of that. Okay? Half as much. All right, so again, hope that made sense. For number 2, you may want to look at numbers 2, 3. I believe there's a 4 and a 5 down there, and try to do those now. Pause your computer, see if you can figure those out. I'm going to quickly go through them, but you want to challenge yourself and see if you can figure those out on your own. Okay? So go ahead and pause your computer. All right, so I'm going to continue on and just help you figure out what the rest of these angle measurements are going to be. I think the easiest one in number 2 is to go ahead and take the inscribed angle like we talked about 2 days ago or yesterday. And okay, if that's the angle measurement right there, this arc, the intercepted arc, has to be twice as much. So this is 70 degrees. The inscribed angle is half that, so if we double it, we get the intercepted arc. From there, I know that this arc right here is also 180 degrees because it's the center right here, so this is the diameter that cuts the circle in half. So as a result, we know that this angle measurement is going to be 90 degrees. Now, we also can go back to what we talked about at the very beginning of this chapter in section 11.1, which said if you have a tangent line to the radius of a circle, they're always going to be perpendicular to each other. Okay? Another way you could have figured out what x is going to be there, we obviously know that this is 70 degrees. If I go ahead and take 180, which is a half circle, minus 70, that gives me this arc measure, which is 110. Okay, 110 degrees. Now, hopefully that makes sense to you. This arc right here is smaller, the length here, than this one, so the degrees will be smaller as well. And so if this is 110, then this angle right here will be 55 degrees. And if we take 55 and 35, that makes 90 degrees. We know the straight line is 180, so this is going to be 90 degrees as well. So again, trying to give you some other options as far as figuring out what the measure of those degrees will have to be. For number 3, we've got a vertex angle and an isosceles triangle, which is 54 degrees. Well, we know that if we have congruent sides, the angles opposite have to be congruent as well. So this angle here and this angle here are the same. So I'm going to focus in on the triangle, not worry about anything else, and I'm going to figure out y degrees, I'm going to do 180 minus 54. That'll give me the sum of those two angles together. And then if I divide that by 2, it'll give me each angle its individual measurement. So 180 minus 54, that's 126 divided by 2 is 63 degrees. I want to double check me on that. 130, 126, 63. Yep, okay. All right, so y is equal to 63 degrees. Okay. Now from there, I'm also going to use this angle right here and show that that inscribed angle intercepts this arc right here. Well, that arc is going to have to be 108 degrees if I double the inscribed angle. All right. Now, I know this is kind of getting kind of busy. Maybe I'll clear it off for you so you can see things better. We know this is 63. We know this is 108 degrees. Okay. From there, this tangent line with this chord will cut this arc in half. So this arc measure, we already know is 108 degrees, so z will be half as much, 54 degrees. Okay. And then to figure out the other angle, you could go ahead and do this. If you know this is 54 degrees and this is 63 degrees, to find x, you could take 180 minus 63 minus 54 and figure out what your measurement's going to be there for x. 110, 117 from 180 is going to be 63. Okay. Now I shouldn't be, let me think here for a second. Yeah, I shouldn't be surprised that's 63 degrees, being that's the same thing as y over here. And here's why. We talked earlier that if we have congruent chords, so this chord here and this chord here of the circle are congruent, that means we have congruent arcs. So this arc here and this arc here will have to be congruent. So if I go ahead and double this inscribed angle, okay, and we know that this one's 63 degrees as well, I can double this inscribed angle. Okay, again, we're going to get 63 degrees there. I know that's a lot of information. I hope you understood one of those there, but the busier the pictures get, the more ways you can possibly solve the problem. And so that's another thing that you can do there. Okay? All right, now for the last two, I believe there's just two more, we get pretty busy. Okay, so what can we do here in number 4 to figure this problem out? Well, first of all, I want to make sure you understand that y is talking about this angle right here. It is not referring to the arc measure there. So just something to clarify that. I think the first thing I would probably do is go ahead and take my arc measure of 240 and subtract that from 360 to get this arc measure right here. Now, before I do that, let me make this a little bit bigger for us so that you can see specifically what we're talking about. It's easier when it's a bigger image. Okay? So again, 240 from 360 gives me this arc measure over here. So what I'm going to do, that's going to be 120 degrees. Okay? That's that arc measure right there. Now from there, I know that if you have a circle and you have a center point and you have a central angle, okay, and this arc measure is 120, what do we know about the central angle? Well, it's the exact same measure because they are congruent to each other. All right, so that's what we're seeing here, that since this arc measure is 120, this angle measure there at the center is also going to be 120, so x is 120. Okay? All right, now if I break this picture apart again, number 4, to find z, here's what you're kind of looking at. Okay? You've got this radius there. Actually, undo that. I don't want to do the radius. I don't even need the center. I'm just going to go ahead and draw the chord that goes across to make angle z. So we've got this chord right here, and we've got this tangent line right here. Okay? And I know right now that this arc is 120 degrees. Well, this angle right here is intercepting this arc. Okay? Chord, tangent line, just what we've been talking about. So this angle right here is going to be half as much, and that's going to be 60 degrees. So z is going to be 60 degrees. Okay? Now from there, there's several different things we could do to figure out the other angle for y. The first thing I guess that comes to my mind is this. If I look at this picture and I look at the two tangent lines, we talked earlier that tangent lines to a circle from a common point are going to be the same length as each other. So this length here is the same length as this length here. Now as a result, I'm going to redraw that triangle that we have. Okay? This is y degrees down here. If this length here is the same length as that length there, which is what we talked about earlier, then I know that this angle over here has to be the same measure as this angle over here. Okay? You could look at it from the other perspective of having a tangent line and a chord, and again, this intercepted arc being 120 would make that 60 as well, but I guess I was thinking more along the lines of the two tangent lines being equal in length to each other. So in order to find y, you can take 60 and 60 from 180, and you're going to get 60 degrees as well. Now, is my picture drawn to proportion? Does this look like an equilateral triangle? I really don't think it does. The picture might be stretched a little vertically right here as I do that, because the circle does look a little longer here to here than it does here to here. So that's probably just a little bit of a warp, but that's how you would find all the angle measurements there. Okay, let's talk about the last picture right here. Okay, very similar to the previous one. Just a couple of things to think about. First of all, if we have a central angle measure, I know it's equal to the arc measure here. This is 100 degrees right here. So if I make a little note of that that's 100 degrees, I think I'll do something like this. that angle and that angle the same. I'll just make a little note to myself. Now, in order to find x degrees, I'm going to redraw this picture so I can see everything. And basically we have something like this. Chord, tangent line. Okay? And we know that this arc right here is 100 degrees. So as a result, this angle measure, as we've talked about, has to be 50 degrees. It's half as much. So I know that x is going to be 50 degrees. Okay? Now from there, again, you can do several things here. A different way of doing it from the previous problem, like I said, I would probably attack it from the aspect of the two tangent lines. This is y degrees again. The two tangent lines have to be equal in length to each other. Okay, so it forms an isosceles triangle, making these two angles 50 and 50. But let's say that doesn't resonate with you, that you're not understanding how to get y degrees right here, which will end up being 80 degrees. What else could you do? Well, I'm looking at this quadrilateral right here. Let's try something with that. If you have that quadrilateral, that kite, you have something like this. I know that this length and this length are the same. I know that this length here and this length here are the same. I also know that the radius to the tangent line, point of tangency, has to form a right angle. So that has to be a right angle. Same thing with this one over here. So as a result, if I know that this is 100 degrees, another way to find y degrees would go ahead and take 360, because we have 4 angles there. So y would be equal to 360 minus 100 minus 90 minus 90, and that will end up being, let's see here, 180, 280. So 280 from 360 is just 80. Okay, it's just another way you could do that. So hopefully you didn't find those concepts too hard. I know the hardest thing probably for most students is the ability to section apart a picture and not look at the whole picture, but look at it in parts. And that's what I want to encourage you to do, which is why I drew a lot of the pictures separate of each other. Okay? And so now in your homework, if you struggle with one of the problems, I want you to draw it separate, see if you can figure it out. And if you still can't figure it out, I'd love to help you come tomorrow. So homework is online. Make sure you wrote down the notes for this lesson and show the sub, and I will give you the, we'll do the homework together, or we'll talk about the homework during our next class. Okay? So have a great night, and I look forward to seeing you guys tomorrow. Goodbye.